Looking at the following, we're going to start comparing IMF's intermolecular forces with that of table H in our reference table. What I want you to do is I want you to take a second and draw the interaction between some of the polar molecules and the other polar molecules. Straight line depicting attraction, while the dotted line represents repulsion. So when we look at IMFs in table H, we have two terms that we have to talk about. Volatile, which means escapes easily to gas phase. It goes to a gas very quickly. And we have vapor pressure, which is kind of a term that we've already talked about, which is the pressure of gas molecules on the surface of a liquid. So we talked about, when we talked about ideal gases, the pressure of the particles on the container. When we talk about vapor pressure, we're talking strictly on the surface of a liquid. So table H gives us 4 different liquids. By looking at these, we can actually determine the boiling point and also some other properties of the liquids. So when we're looking at these, we want to look at which of the following most easily escapes to the gas phase. Which one of these has a boiling point at 80 degrees Celsius? Which one has the highest or the strongest intermolecular forces? By looking at the table on table H, you can see that we have 4 different liquids. The line is the boiling point. Boiling point, remember, is equal when the vapor pressure and the atmospherical pressure are the same. So the pressure of the gas interior to that exterior of the container. So, most easily escapes to gas. Which of the following looks like it escapes most easily to gas? By using your test taking strategies, you should be able to at least eliminate ethanol and water. By looking at these, you're going to see that propanone is the liquid that most easily escapes to the gas phase. Why is that? Well, you can see that at a lower temperature, less average kinetic energy, our propanone is boiling much quicker. This line is above this line. Thus, this line again representing the boiling point. And if we are boiling, we are now changing to the gas phase. Has a boiling point of 80 degrees Celsius at STP. Well, we know STP based off from table A is 101.3 kilopascals. As we follow this line across to 80 degrees, and you go up, you know that this is indeed going to be the boiling point of ethanol. The next one we want to talk about is the strongest intermolecular forces. So as we know that this line depicts the boiling point, if you're changing to a gas rather easily, do you have strong intermolecular forces? Can your particles spread out quicker? Well, with a strong intramolecular force, we know that you cannot turn into a gas very easily. So you need more temperature in order to change. So which one of the following needs more energy in order to change to a gas? Well, that's our ethanoic acid. As you can see on table H, ethanoic acid is the lowest curve of the 4 liquids. Our next question is, if the pressure is reduced to 50 kilopascal, boils at approximately 82 degrees Celsius. So if we're at 50 kilopascals and we're at 82 degrees Celsius, who exactly boils? So looking at that at 82, roughly looking, you are going to be looking more at water. The last one is which is most volatile. So volatile, which is a vocab word we talked about earlier, which means escapes easily to the gas phase. So which one of the following escapes to the gas, which is actually the same question we answered earlier. We know that, again, that's propanone.